Uh, Hello, everyone. This video is about Doppler effect. Now, what happens in a Doppler effect is that if the source of the sound that is producing the waves, if it is moving, then the people who are in front of that moving car or moving object, they will hear a frequency which will be different from the original frequency that is emitted by the source of sound. Or the people who are behind the source of sound that is moving away, they will also hear a different frequency. So when the apparent frequency or the heard frequency is different from the emitted frequency, that is called Doppler effect. So as you can see from here, because the moving source is catching up on the sound waves which are moving in this direction. So as a result, the waves, they have got less space to be occupied. So wavelength appears to be smaller. If wavelength is smaller, that means, and since the speed of the sound in air is constant, V equals F lambda, so a smaller wavelength means a higher frequency. So the person towards whom the source is approaching, he will hear a higher frequency. A person behind the moving source will have waves will become, or the wavelength will become longer. And since speed is constant, so this person will hear lower frequency. So this apparent change in frequency because of the moving source is called the Doppler effect. Sometime you could be asked to draw. So if the source of sound was stationary, that means as the waves move in all different directions, people will hear the same frequency because the wavelength does not change. But here, you can see that as the source is moving in this direction, wavelength does not change, but it appears to have changed because they've got less space to occupy. So how do we find the apparent frequency heard by a source? So that's the formula. F dash is the apparent frequency. That's the emitted frequency. That's the speed of the sound wave, and which is constant in air. And that's again the speed of the sound waves and plus minus speed of the source. Now, negative is used when the source is approaching towards the person. And so negative means that this part over here will be smaller than that one. So as a result, the whole factor will become bigger, or the apparent frequency will be higher. If the source is moving away, for a receding source, plus sign is used, and then apparent frequency will come out a smaller value. Now, this is a quite useful phenomenon in terms of speed detecting cameras. They use this Doppler effect. And sometimes you hear sonic booms when the planes are flying at a speed higher or closer to the speed of sound. So that's when the sonic boom happens. What is redshift is, now this Doppler effect happens in all different types of waves, whether they are sound waves, or they are light waves, or they are microwaves. So if light waves are moving away from us observer, so for example, stars, this space is expanding, and therefore all the stars are moving away from each other. So apparent wavelength of a light from a receding star will have a lower frequency, and lower frequency means that instead of color of the spectrum will be more towards the red, and because red light has got lower frequency and longer wavelength. So that's what a redshift is. So thank you for watching this video.